Now, we were emphasizing the importance of solvents. These solvents should be such that they are also not toxic and they are having reasonable boiling points, not very low boiling points, because it will evaporate very readily and make the environment polluted. The solvents also should have reasonable solubility for the various organic compounds. The reaction la use பண்றதுக்கு solubility வேணும். These are requirements of green solvents, mainly green solvents. அது வந்து கம்ப்ளீட்டாக you will be able to recycle that. You use it one time, again distill, you may lose some amount or 10% loss, and the 90% it is being recycled. And the recycle illadhu, it will pollute the factory, and you must have proper collection system. Or usually factories there will be lower pressure inside the factory than outside. So air will, that's called laminar flow. Air வந்து கீழேந்து உள்ளே வந்து இந்த ரூமில் இருக்கிறத வெளியில் கொண்டு போகும். அங்கேருந்து இதில் டியூப்ஸ் எல்லாம் வச்சு you must be able to condense the vapor, or sometimes the vapor வந்து acidic-ஆ இருந்தால் அதை you can put it in sodium hydroxide or sodium carbonate solution, you can absorb it. There are various ways of treating the excess solvent. Renewable solvents are environment friendly. If you are able to recycle the solvent, that is environment friendly. Water, methanol, ethanol, dimethyl formamide, DMF is called dimethyl formamide, acetonitrile, dioxane, acetone, furan, chloroform, benzene, ethyl acetate, toluene, carbon tetrachloride, cyclohexane and hexane. இதில் வந்து எல்லா சால்வெண்ட்டும் வந்து they can be used, but not all of them are non-toxic. சிலதெல்லாம் very toxic. Benzene, for example, is carcinogenic. It's not usually used as the solvent for reactions. Chloroform is anesthetic. You can give the chloroform and people will go into deep sleep. It was used earlier for surgeries. Furan is okay, toluene is okay. Once you put a methyl group on benzene, அது வந்து அவ்வளோ டாக்ஸிக் இல்லை. ஏன்னா மித்தைல் குரூப் வந்து biodegradable. It can get oxidized to aldehyde, carboxylic acid, and அதெல்லாம் வந்து environmental it can be easily biodegradable. Carbon tetrachloride is a very bad solvent. This chlorine is not easily removed. அது வந்து அப்படியே environmental it will be stagnant. It cannot be very safe. Cyclohexane is okay, hexane is okay, but hexane has very low boiling point. Hexane la use பண்ணாக்க it is used only in very contained situations. The reactor should be contained. At the end of the reaction you should be able to get the hexane out. அதை வந்து ரீசைக்கிள் பண்ணுறதுக்கு வசதியாக வச்சுக்கணும். Solvents have great influence of the ratio of the products of the reaction where there are more than one product as outlined below. Solvent use பண்ணாக்க the proportion of products, if there are two products formed in a chemical reaction, ஒரு solvent use பண்ணாக்க ஒரு proportion வரும், இன்னொரு solvent use பண்ணா இன்னொரு proportion வரும். அந்த solvent different concentration use பண்ணாக்க the product ratio will be different. Look at one of those reactions. So this is another Diels-Alder reaction. Instead of using butadiene, which is an open compound, open chain compound, this is a cyclic compound, is cyclopentadiene. 5 carbons is pentane, cyclopentane. அதில் 2 double bond இருக்கு. It's called cyclopentadiene. This is reacted with the ketone here with a double bond. It's called acrolein, and this particular thing will produce fused ring, this ring plus this ring, and the remaining ketone will be here. Of course, here the atom economy is 100%. But there are two products. This product is endo product. Suppose you have this CH2 group here is above and this CO group is below. This is called the endo product. இங்கே இருக்கிற substituent கீழே இருந்தாக்க it's called endo. இந்த substituent மேலே இருந்தாக்க it's called exo. These are the two different products that are formed in this reaction. This is the Diels-Alder reaction. This was investigated by Professor R. Breslow. He was working in Columbia University. This is the publication JSCS, Journal of American Chemical Society, and these are the year, the volume number and the page number. The endo-exo selectivity increased from 3.5 to 21.4, going from isooctane to water. The endo வந்து இங்கே போட்டிருக்கோம். ethane it is 50%, A to B is 76 to 24, 50% ethane. Water it's 55% to 45%. This is the endo isooctane இது வந்து endo is 1, water the rate is 740. Effect of solvent on ring opening of styrene oxide. This is organic letters 2005 year 73469. This is the styrene oxide. The styrene வந்து double bond attached to the benzene ring. அது வந்து if you treat it with oxygen under silver catalysis, it forms a 3-membered oxygen containing ring. It's called oxyrane. This is the 3-membered ring. When you treat it with diethylamine, it reacts at both the position, either here or here. If it reacts here, you get this particular compound. If it reacts here, you get this compound. OH will come next to benzene ring, and this will come on the second carbon atom. Here, if you use ethane as a solvent, the yield is 50%, A to B is 76:24. So, this is 2:1. If you use water, the yield is 92%, and both of them are close to each other, 55:45. So, the solvents have very important factor to determine the ratio of the products when two products are formed in a reaction, and you can choose a particular solvent which produces the desirable amount for your synthesis. Then next is phase transfer catalyst. The phase transfer catalyst வந்து suppose these are usually made of a very large hydrophobic group, and it is ending with a hydrophilic group. The best example is soap. Soap வந்து முன்னெல்லாம் இந்த fats and oils hydrolyze பண்ணி soap பண்ணுறது. The hydrolyze பண்ணாக்க the final product will be a carboxylic acid, a mixture of carboxylic acid. அந்த carboxylic acidலாம் 8 கார்பன்லேருந்து ஆரம்பித்து 18 கார்பன் வரைக்கும் போகும். The 18 carbon chain, at the end of it 17 carbon chain, at the end of it a carboxylic group is the normal picture of a phase transfer catalyst. So, the catalyst will go, the COOH group will be hydrophilic, that end will be sticking out of the water. The other end, the large C17 group will be sticking inside water. So, this is the general structure of the carboxylic acid with large amount of carbon. So, the hydrophilic group will be out, hydrophobic group will be in, and when you have a compound, depending upon its polarity, அது வந்து highly polar இருந்தக்க it will be very near the surface. The highly unpolar it will be inside this phase transfer catalyst. The other one will be outside the phase transfer catalyst. Now, we will look at this phase transfer catalyst consists of a large hydrophobic hydrocarbon chain with the hydrophilic ionic group. With water, it will form two phases. If mixed, depending upon the solvent, the two ends will be orienting themselves so that the polar end will face outside in the case of hydrophilic solvents. In the non-polar solvents, the hydrophobic end will face outside as expected. I just mentioned that. A spherical molecular aggregate called micelle is formed. This starts like in a, so you have a beaker of water. First, all the water surface will be full of carboxylic acid. The inside the surface, you have the carbon chain, which is the hydrophobic. So, it will form eventually a sphere. All the carbon chain will accumulate together. So, it will be a sphere. At the bottom, you have a sphere. At the top, you have the end of the sphere containing the carboxylic acid. This particular spherical formation is called micelle, M-I-C-E-L-L-E. Depending upon the spherical molecular aggregate called micelle is formed. Depending upon the nature of the reactant, micelle will be penetrated by reagents of similar properties, polarities, and reactions take place at great speeds. Once the micelle is formed, depending upon the micelle will be depending upon the solvent. If it is hydrophobic solvent, the outside of the sphere will be hydrophobic. Inside you have the hydrophilic group. But if it is like water, which is hydrophilic, in the sphere you will have water sticking out and the carbon chain sticking in. அதில் வந்து போலார் மாலிகுல்ஸ் இருந்ததுனாக்கா இந்த வாட்டர் சர்ஃபேஸில் இருக்கும், அந்த ஸ்ஃபியரோட சர்ஃபேஸில் இருக்கும். நான் போலார் மாலிகுல்ஸாக இருந்தால் அந்த ஸ்ஃபியருக்குள்ளே போயிடும். இந்த ரியாக்டன்ஸ் எது ஆல்சோ பேஸ்ட் ஆன் த ரியாக்டன்ஸ் மே பி போலார் ஆர் நான் போலார். According to the polarity of the solvent and the reactant, you will have ability of the reactants going into the same area where either you have polar, the polar molecule goes into polar area, the reaction will be speeded up for polar molecules. If non-polar molecules go into non-polar part of the sphere, the non-polar molecular reaction will take place very fast. One of the examples of phase transfer catalyst. This is one example, CTAB. This is a cetyl. You have 16 carbons and a nitrogen which is polar. It is attached to 3 methyl group. When you have 4 alkyl group, nitrogen la irundaka adu positive charge, alkanium ion or ammonium ion. Bromide is the counter ion. இதை வந்து வாட்டரில் போட்டாக்க இந்த NMe3 plus will be on the surface and eventually form the sphere with this at the surface of the sphere. This will be inside the sphere. This is cetyl ammonium bromide. This is a tri-tertiary butyl aluminum bromide, tetra-tertiary butyl aluminum bromide. 4 molecules of C4. C4 is in this case is a tertiary butyl group. There are 4 tertiary butyl groups. The tertiary butyl group is like this. We have seen it earlier. So, this is the C4H9. and this is attached to the amino group, and it will form, this is 4 carbons put on the nitrogen, either positive charge, tetrahydrobutyl aluminum ammonium bromide. This is the other phase transfer catalyst. So இந்த catalystலாம் இது வந்து either வெளியில் இருக்கும் or இது வந்து உள்ள இருக்கும் or vice versa depending upon the polarity of the solvent. போலராக இருந்தால் இது வெளியில் இருக்கும், நான் போலராக இருந்தால் இது வெளியில் இருக்கும். So this is a reaction conducted in a micelle. Micelle அந்த spherical structure, அந்த spherical structureல வெளியில் இருக்கிறதெல்லாம் போலராக இருந்தாக்க அது வாட்டரில் ரியாக்ஷன், வெளியில் இருக்கிறதெல்லாம் நான் போலராக இருந்தால் அது சம் ஆர்கானிக் சால்வெண்ட்டில். ஸோ இன் திஸ் கேஸ் amine is reacted in the presence of CTAB, cetyl ammonium bromide. This is dinitrophlorobenzene reacting with the aniline. The aniline group displaces the fluorine, and this is done in micellar catalysis in cetyl ammonium bromide, and this reaction is very fast in this micelle. This is the reference of the authors who did this reaction: aromatic nucleophilic substitution with phase transfer catalyst with cetyl trimethyl ammonium bromide, CTAB, Journal of American Chemical Society, 1970, 92, volume 356 page. Next, another solvent which is totally different than all these things. We have seen so far mostly organic solvents, organic reactants and products. Now you have a totally different type of solvent. It is called supercritical carbon dioxide. Just like the phase diagram of water, the carbon dioxide, if you subject it to different temperatures and pressures, அது வந்து வெவ்வேறு phase form ஆகுது. At 400 degrees and 10,000 pressure millipascal bar, 83.8 bar, that is the atmosphere. You get this point. From there up to here, the pressure of about 100 millipascal. This is 72 atmosphere, the 83.8. This is 1070 psi, or the in pounds per square inch. Now, if you have the pressure and temperature is 10,400 degrees Kelvin and 10,000 millipascal, you get this portion. Up to this portion, 100 and 400 comes, or 300 comes. This is in the form of a fluid. It is called supercritical fluid. If you change the conditions, it will become gas. Then this is the critical point where liquid, supercritical fluid and critical point gas are all present in this point. Then you find gas in this area and liquid in this area. So this is the phase diagram of carbon dioxide. What is very important in the green chemistry lab, the solvent வந்து we have seen different solvents, organic solvents. நான் ஒரு லிஸ்ட் கொடுத்துருந்தேன் solvent. இது வந்து sort of inorganic compound. இது வந்து carbon dioxide at very high temperature and pressure produces this supercritical fluid. இது ஒரு solvent. இதை வந்து எம்ப்ளாய் பண்ணி சில ரியாக்ஷன்ஸ் எல்லாம் பண்ணலாம். இது பண்ணாக்க at the end வந்து the carbon dioxide can be taken out as gas and it can be recycled. So it is environmentally very friendly. Reactions using supercritical carbon dioxide. take an olefin, alkene, oxygen, catalyst and supercritical carbon dioxide as the solvent, and do photolysis. In photolysis, you get radical here, and that reacts with oxygen, which picks up hydrogen. So, this is the compound that is formed. The double bond moves from there to here, one electron moves here, the other electrons move here and reacts with oxygen and forms this compound. This is the supercritical carbon dioxide solvent reaction. This is given in this paper, singlet oxygen in supercritical carbon dioxide, chemical communication 2008 4457 page number. This is another reaction, supercritical carbon dioxide solvent. You have this orthocresol, it is reacted with the bromine, hydrogen peroxide, sodium bromide, hydrogen peroxide, sodium bicarbonate, water, supercritical carbon dioxide at 40 degrees. So, what happens here? It does a bromination reaction. The yield depends on the presence of one or other of these compounds. So, what happens here is a bromination of the orthocresol with bromine para to the hydroxyl group. Generally, as the electrophilic substitution, bromine Br plus attacks the para position. Hydroxyl group, electron donating group, adanala the incoming Br plus gets attached to the para position. The electrons here will move here, from here to here, from here to the Br plus. Water without sodium bicarbonate, if you do the reaction, the yield is 12%. Water supercritical carbon dioxide without bicarbonate, you get 54%. Water supercritical carbon dioxide with bicarbonate, you get 91%. So, the supercritical carbon dioxide and bicarbonate makes a lot of difference in the yield. This reaction is described in this paper, oxidative bromination of phenol in supercritical carbon dioxide. This is the journal Green Chemistry 2007 volume 9 page 26. Ionic liquids. This is another very interesting solvent. The ionic liquids has a melting point less than 100 degrees. In the recent years, ionic liquids have established itself as a green solvent. They are characterized as a non-molecular solvent with high thermal stability, low flammability, non-corrosiveness, moderate conductivity, low viscosity and negligible vapor pressure. A whole lot of things. What it does is, it has a the cation and an anion, and this mixture of cation and anion get this kind of properties for this liquid, that its melting point is less than 100 degrees and is able to do all these things: thermal stability, low flammability, non-corrosiveness, moderate conductivity, low viscosity and negligible vapor pressure. Negligible vapor pressure means the ionic liquid gas varadu. So, it won't pollute the factory atmosphere. Non-corrosive means all the reactant vessels, they will last for a long time. High thermal stability means it can be easily recycled. The most common cation in ionic liquids is imidazolium ion. The other cations are ammonium, phosphonium, thiazolium, and triazolium, etc. Anions are usually tetrafluoroborate, hexaphosphate, tetrachloroaluminate. So, it is a product by the mixing of a positive charged ion from an organic compound and a negative charged ion usually from inorganic reagent. The organic part is imidazolium ion, you will see what they are, and ammonium ion, phosphonium ion, that is also familiar to you, thiazolium ion and triazolium ion. Anions is tetrafluoroborate. We have seen this earlier in the production of fluoro compound from diazo compounds. You make diazo tetrafluoroborate, heat it and you get fluoro compound. Hexaphosphate, PF6, tetrachloroaluminate, Al with 4 chlorine. Ionic liquids, 6 MIM, this is methyl imidazolium, this is the MIM stands for, and PF6, this is the phosphonium compound PF6, 1 cyclohexyl 3 methyl imidazolium PF6, this is called 6 MIM. X6 stands for F6 PF6, and methyl imidazolium compound, this is methyl imidazolium compound. This cyclohexyl is not shown as a letter. This 1 butyl 3 methyl imidazolium PF6, instead of instead of cyclohexyl group you get a butyl group. This is 1 butyl 3 methyl imidazolium PF6. This particular compound is produced and by scientists and reported in the tetrahedron letters 2002 year 43 volume 4993 page. So, to see this more clearly, this is called imidazole. When you have 5-membered ring with 2 nitrogens, 1,3 position, this is called pyrrole. This is called pyrrole, 5-membered ring with 1 nitrogen. When you have another nitrogen here, this is the imidazole. When you react the imidazole, usually this has a hydrogen. When you react with cyclohexyl bromide, this nitrogen here will react with cyclohexyl compound, HBr will go. And if you react with another molecules of methyl bromide will attach it to the other nitrogen and you have a quaternary salt. When you have 4 groups, 2 here, 1 here and 1 here, 4 groups, you get the quaternary salt, that is methyl cyclohexyl imidazolium bromide here. When you add PF6, you get the corresponding hexaphosphate. Therefore, this is MIM PF6 minus. So, this is the compound which is the ionic liquid which has boiling point less than 100 with all the other properties, patha properties. Organic reactions using A is this compound, this methyl cyclohexyl imidazolium hexaphosphate, hexafluorophosphate. So, if you treat this aldehyde with dicyanoMethane, this is derived from malonic acid. The malonic acid is converted to diamide and then dehydrated, you get this CH2CN twice. And this on reaction with this amino acid in the presence of this MIM, 6 MIM, and at room temperature, this undergoes condensation of the aldehyde with this. This is called Knoevenagel condensation, This forms anion and reacts with this aldehyde and eliminates a molecule of water, and you get this diacyano compound. This is called Knoevenagel reaction, this condensation. This done in 6-mem PF6 tetrahedral letters 2001, 42, 60, 53. This is another reaction with 6-mem hexafluorophosphate. You take phenylacetylene, this is phenylacetylene, reacted with KBr, hydrogen peroxide and ammonium molybdate, then treated with water in the presence of this solvent and 6-mem PF6, this ionic solvent. So, it adds the bromine, 2 bromines are added to the alkene, and you get the water coming at as COH, which gets oxidized CO. This is the reaction where the acetylene is converted to dihalomethyl ketone. This is reported in Advanced Synthetic Catalysis 2005 year, 347 volume, 1341 page.